All right, mathletes. So let's dive in here and let's look at how to find how to use this product rule for derivatives. All right. So here's the idea before we dive in. Number one, we're gonna have a product, right? That just means a multiplication, and it could be, in this case, I'm gonna pretend these are two separate functions being multiplied. That's the way I'm gonna treat this. There could be multiple, right? But here, we're going to look at, hey, what happens when we have these two functions being multiplied? And that's the way we want to break it down as two, and you'll see why. So what I'll do is I'll say this is my function f of x, and we'll say the second product, we'll call it g of x. And when I find the derivative, right, which is y prime, right, the derivative, what the rule says to do, and what's nice about it, is the order really doesn't matter because of the commutative property of addition. It says you take the first function times the derivative of the second, and again, we could change the order, and it's not going to matter. And then you're going to add the derivative of the first function times the original second function. Right? So this is going to be the rule that we're going to utilize. So it's f times g prime plus f prime times g. And again, we could have said f prime times g and then plus f times g prime. Again, the order doesn't matter because these are being added and we have that commutative property there. So our job is going to be to go and find this f prime and g prime so we can substitute it in to this formula. All right, so let's go in here, let's dive in this. So we know that f prime, we called this, f of x, we called 2x plus 1. So to find the derivative of that, well, that's fairly easy. That's just 2, right? Because the derivative of 1, that's a constant, so that's 0, it goes away. And then the derivative of 2x, that's just 2. Nice. Let's go ahead and find the derivative of g of x. And we said that g of x is 3x squared plus 5, right? Another nice derivative. It's going to be easy to find. So our derivative here, remember, we're going to multiply that by 2. So the 3 by 2, we'll get 6. And then we're going to drop our exponent down by 1 using that power rule. And then again, we have a constant. The derivative of a constant is 0. So there's g prime. So what you need to make sure that as you're using this rule, you have to get really good at taking basic derivatives and knowing those techniques that you're going to learn later. It's going to make this so much easier. All right, so now let's just go ahead and plug in all our components into y prime here. So now we know our derivative, y prime, is f of x, which is 2x plus 1, I'm going to put that in parentheses, times g prime, and g prime is just 6x, plus f prime, which is 2 times g of x, which is 3x squared plus 5. So there, my friends, is the derivative. And again, you can go ahead, multiply everything out, and just make sure, what's the goal? Usually we're doing something else with this derivative. So right now, I'll just leave it like that. So again, all we're doing is you take the first function times the derivative of the second, that's this, plus the derivative of the first function times the original second, and that's this component. So again, it's that easy. So let's get some more practice, right? Let's do another problem. Follow me. All right, so I added a few things here because I want to shake things up, because the biggest problem students have with this that you might notice yourself is notation. What are they asking me to do? So the last thing I want you mathletes to do is just to memorize, okay, I do this, this, and this, and that. I want you to understand, right? Understanding is key. And a huge part of you understanding this is smashing that like button and subscribing. So don't forget to do that, right? Show us some love here. So first things first, look what they want. They want f of 1. So a large part of calculus, right, is you really understanding all your algebra, right? And here, right, this isn't calculus. This is just saying take that function and plug in 1. So I don't even need any of these rules yet. So let's go ahead and do that. And so often, we forget what's really being asked of us. So we take that 1, we plug it in, and we're going to evaluate this for x equal to 1. All right, so we use our order of operations. We get 1 minus 4. That's going to give us -3, and then we're going to have 2 minus 3 there. So we are left with -3 times -1. So we're left with 3. So f of 1 here is 3. So that's very different, right, than f prime of 1. Because what they're wanting us to do here is first we're going to take the derivative of this original function, and then after we do, we're going to examine the derivative at x equals 1, right? We're finding that slope at x equals 1. So we're finding that slope of that tangent line. Where is it tangent to? Boom, that point x equals 1. All right, so let's go ahead and let's find this. And I just want to remind you, the point we're going to be examining is the point 1, 3, if we were to graph this, right? So that's where that tangent line is going to cross. It's going to cross the point 1, 3, right? Because this was our outcome, our y value. All right, so let's go ahead and find that slope. So first things first, we need to find f prime of x. We need to find f prime. And what we're going to do is we're going to take that first function, and I'm going to give you some new notation just so you feel confident, so that you get confident with all this. And then we're going to multiply it times the derivative of the second function. So I'll put that little prime symbol, right? So you're going to take the derivative of that. And then we're going to add, now we're going to take the derivative of that first function, right? And then multiply it by the original second function. And again, the reason I'm saying second function is because we're treating this as our first function, and we're treating this as our second function. And we're looking at it as the multiplication of two functions, right? And so now let's get to work. Let's go ahead and find the derivative of 2x minus 3. So we'll call this function, let me do you guys, just because we're barely learning this, let's call this function u of x, right? So a lot of textbooks, they'll use u, and then this function we'll call v of x. We just got to be careful and make sure we make that v really sharp so you could tell the difference. So u of x, and again, these are just names. You could call it g of x, h of x, doesn't matter. U of x is x squared minus 4, so u prime of x, right, the derivative of that is just 2x, because I bring this 2 to the front, and this I drop it by 1. The derivative of negative 4, that's just 0. Now let's find the derivative of v of x. I'll make it here in red. So v of x is 2x minus 3, so v prime of x is just 2. Well, that's awfully nice there. All right, so let's go ahead and now let's go back to what we were doing before we went to commercial break. So we found we needed to find this right here. So x squared minus 4, that stays the same. X squared minus 4, but now we want to multiply it times the derivative of this 2x minus 3, and we called that v of x. And the derivative of that was just 2. So let's actually just bring the 2 in front there. Alrighty. Plus, so plus, I'll get that plus there, the derivative of x squared minus 4. And this, right, we called, what do we call that? We're finding the derivative of u of x. So the derivative of u of x here is just 2x. And I'll do a breakdown just in case you got lost. All right. And then times 2x minus 3. So Dr. Math, what did we just do here, right? So check it out. No need to hit the panic button. Let's look at our original function, right? Walk with me. Look at this original function way up here. All right. So what did we do? We took this original function, x squared minus 4, x squared minus 4 times the derivative of that second function, which we found just to be 2. And that's this, right? Plus, Now we take the derivative of the first function, which is 2x, that's this piece right here, times the original second function, which is 2x minus 3. And that's all we do right there. If you want to distribute everything, that's fine, but look at what we're going to do next. They want us to find f prime of 1. Well, we just found f prime. So now, wherever we see x, now let's go ahead and plug in that 1. All right, so f prime of 1. So we're left with 2 times 1 squared, I'll put that in parentheses, just so we develop some good habits, minus 4, plus 2 times parentheses, and we know there's a 1 going in there, times 2 times 1 minus 3. So all we did is wherever you saw an x, we're multiplying it by 1. And we know when you multiply by 1, nothing's going to actually change. So all we have to do now is simplify. So we're left with 2 times, you got 1 squared, which is 1, minus 4. So you're going to get negative 3 plus 2, right? This gives us 2 right there. And in parentheses, you end up with 2 minus 3. So a negative 1 right there. So you're left with negative 6 minus 2, which gives you negative 8. So at this point, 1 comma 3, right? Whenever you're looking at this graph, and this is going to give us actually a cubic function if we were to multiply and distribute everything, what you would see there at 1 comma 3 is that tangent line. When you were to draw that tangent line, it would have a slope, right? It would have the slope of negative 8, because that's the derivative at looking at x equals 1 here. All right, folks. So hopefully this was helpful. And again, we want to I'm just working it, looking at all the different notation and things that you're going to be doing with these derivatives. So let's take a look at another example. All right, so here's the last one I want to do, kind of using the product rule here. And what you're going to see here is what they ask us to do is to find the equation of the line tangent to this function at x equals 1. And what I did is I graphed it. So let me kind of bring in my graph here to kind of show you what is it that we're actually looking for. Because a lot of people, they'll want to follow steps, but they don't realize, you know, what am I looking for? What is it that I'm finding? And that's what I want to point out here. So I use Desmos, our friends over there at Desmos. And what I did is I graphed in red here this function. And if I were to distribute, I would get 2x cubed as my leading term. And so I know this is going to be a cubic function, right? So there's my cubic function. And what I'm interested in is kind of zooming in at x equals 1 and drawing a tangent line there, right? So I remember a tangent line is, if I zoom in, it represents the curve, the slope of that curve at that particular point. So if I'm just focused in, right? So if I like zoom in here, let's see if we could zoom into this graph. You're going to see that curve, the more I zoom in, it starts to look like a line the closer and closer that I get. So what I'm interested in is, what is this equation of that line if I were just to continue and draw out that line, that black line that I have here. So if I were just to continue with that line forever, right, what would that equation be? So that's my goal. And so what we're going to do is, remember, when you're trying to find an equation, right, of a line, well, it's helpful to have the slope. So one thing that we're interested in is finding the slope. And remember, the slope is going to be our derivative of this function at the certain point that we're examining. And that point that we're examining, we know that x value is 1. So what we're going to do is we're going to find f prime, and then we're going to plug in 1. And that is going to represent the slope of that line that we're looking for. And then of course, we're going to need a point. So we're going to need the point x1 comma y1. But what do you notice? They give us x1. They give us x1 as 1, right? They tell us we're looking at x equals 1. So why not go ahead and find y1? So the first thing we're going to do is let's go ahead and find y1. So all we're going to do is plug it in just like we did in our last example. So you could see here that the last example is kind of preparing us for a question just like this. And so let me go ahead and plug it in. Oops, we're plugging in 1, we said. So let's plug in 1 and go ahead and take out your calculator. And this is going to give us 0. So 0 times anything is 0. So what we're looking at is the point 1, comma 0. All right, so now we have our point. So let's go ahead and let's find the slope of that tangent line here. So let's take the derivative of this, and let me set things up. I'll call this u and I'll call this v. And so when I take u prime, right, the derivative of this first product, I'm going to end up with 2x, right? So we end up with 2x. And then I'll do this v part, this second product, I'll do it in red. So we'll say v prime, right? The derivative of this 2x minus 4 is just 2. And if you recall, we said when we take the derivative, so when we're going to find y prime, right, what we're going to do is we're going to take the first function, which is u, and then we're going to multiply it by u prime. And again, we could change the order. The order doesn't matter because of our commutative property, plus u prime times v. And then once again, I could put this first, or I could put, and again, we get the same thing. So don't worry about that. So u, we said, is x squared minus 1. V prime, we said, is 2. U prime is 2x, and v is 2x minus 4. So let's plug all that in to get our derivative. So f prime equals u, which is x squared minus 1, times v prime, which is 2, plus u prime, right, which we said is 2x, times v, which is 2x minus 4. 2x minus 4. Right? And there's our derivative. And remember what we're interested in. We're interested in the derivative. So this will work for any x, right? So you give me an x value, and this will tell me the slope at that point with the x value of whatever it is that you give me. So in this particular instance, they're saying x equals 1. So let's look at what's the derivative at the point 1 comma 0, because now I know that y value. So let's go ahead and plug in 1. So we're going to find the derivative when x equals 1. So let's go ahead and plug that in. So we're going to get 1 squared minus 1. That's going to give me 0. So I know this whole first piece here, all this is going to 0, because here I have 1 minus 1. All right. And then we have plus 2 times 1 times the product 2 times 1 minus 4. And so we are left with, this all went to 0. And so we're left with 2 times negative 2. And I believe we did this in the last example, so it's okay. Giving us more practice. And we get this negative 4. So this negative 4 represents my slope, right, of this line that I showed you earlier, that slope of the tangent line, right, at that point 1 comma 0. So now I have my slope and I have a point. So let's go ahead and plug it in. There's quite a few formulas we could use. Let's just stick with Old Faithful here. Old Reliable. So there's our point slope formula, because now we have a point and we have the slope. So we get y minus y1, which is 0. Nice. Our m is negative 4. And then we have x minus 1. Distribute that negative 4 and you're left with y equals negative 4x plus 4. And if you were to graph this right here, what you would see is that would have given me the slope of, that would have given me the equation of that tangent line when x equals 1 right there. And so again, when we're taking the derivative, when we're looking at that product rule, this is just a tool to help us answer bigger questions, right? So when you're finding the product rule, it's not so bad. All we do is you take that first function, leave it alone, take the derivative of the second function, right, plus the derivative of the first function times the second function. So again, it's just getting that practice, that repetition in, but the work itself is not bad at all. All right, Mathletes. So hopefully this is helpful. Don't forget to smash that like button, subscribe, and we'll see you guys in the next video. Peace.